Hey everyone, in today's episode, we're going to take a zero to hero approach with Azure DevOps. We have a special guest joining us today, Nana from Tech World with Nana. Now, Nana loves everything about DevOps and loves Azure DevOps. So she and I have put together a very special video for you. So please follow along. Now, we also have a lot of resources that you can access as well. So instead of going through 100 links, we have one concise link for you to go through. Now let's quickly walk through how to access the documents, the repository, and more. So you're going to go ahead and click this link below, aka.ms/techworldwithnana. You're going to go ahead, it's going to open this page, you're going to enter in all your details, and ta-da, you're going to have all your links in one place, easy for you to see. Hello, everyone, and welcome to the DevOps Lab. I'm April Edwards, and I'm joined by a very, very special guest. Welcome, Nana.
Hi, April. Really excited to be on the show and really excited about the topic that we're going to discuss today, which is going to be Azure DevOps. So we are actually going to start with a brief introduction of the DevOps in general and the cross-functional teams, and we're going to go through the Azure DevOps platform and basically see the mapping from Azure DevOps features. So we're going to go through all the features and all the amazing stuff that you can do on the platform and basically see how you can use that in DevOps teams in practice.
Awesome. So let's get started. So for everyone out there today that is just starting off in DevOps, I want to level set with you. And I want to first start off with how we define DevOps. Now, this is something how we define DevOps at Microsoft. And I think if I were to ask each and every one of you how you would define DevOps, I would get a very different answer. Some of us have a lot of experience working in DevOps practices, and some of us are just starting from scratch. So I want to level set here. We define DevOps as the union of people, process, and products to enable continuous delivery of value to end users. And I want to focus on this word value, because if you've ever seen some of Nana's videos before, you know she talks about a lot about the tooling, the processes, and the people side of it. And really, 80% of it is the people side. We tend to work in silos in our different organizations, but we want to break those down. And we're going to use the tooling today to help us leverage that. But more importantly, we want to learn how to use the tooling to deliver value to our organization. So let's talk about how our organizations are currently carved up that many of us work with. So we tend to have an organization where we're trying to deliver something. Maybe as an IT pro, you're trying to keep those lights on 24/7, no matter what. And as an engineer or developer, you're trying to push new features. Those two things always conflict. And it's really hard working these silos teams because not only are we incentivized very differently, but we're trying to deliver different things. So we need to come together into product teams, into feature teams even, to deliver that value across our organizations and to our end users. So we're going to talk about a feature team today. This is going to be a cross-functional team. So what does this mean for you? A lot of us work in one space. We might work with data or APIs explicitly, or maybe the user interface. And if you're working in the operational space, maybe you work in storage or just networking, and you don't care about the rest of the stack. And I get it. It's sometimes hard to care about those other parts when you're so focused on what you have to deliver. But if we could develop into more vertical teams, we can have empathy across that stack. And that's really important to having that DevOps mindset. So yes, you might be a UI developer, but learning to understand how your UI impacts that data stack. Or if you're working in storage or networking, you need to understand how that component of your infrastructure impacts the applications you're working on, and even maybe the data components. So let's dig in to Azure DevOps.
So exactly as you mentioned, April, most of the DevOps is about communication, and as it flows to the cross-functional teams, which basically now you have a team with different roles inside, which have aligned interests, right? So basically you have a project where you have lots of different roles, each one having their own background and skill set that they bring to the table. And now they have to work together, and what's important, they have to collaborate. And even though I teach a lot about DevOps tools and technologies, I also completely believe, and I'm 100% behind the idea that DevOps is first the culture and communication, and basically defining what the workflows are and how the team works offline, and then basically implementing that and taking that online and using those technologies to actually bring that online, right? So Azure DevOps and all its features are basically there to map to those offline workflows. So basically, when once you define in your organization how your team is going to work together, how those different roles are going to communicate with each other, who needs to talk to who, how are the roles defined, where the boundaries, etc. Now you have to basically provide them with some tools and platforms to also implement those in practice, right, while working on the project. So all these features that you see here that the Azure DevOps provides is basically one-stop shop, like a centralized platform where each role has their own basically way to do their job, but also very good points of integration between the roles. So in Azure Boards, from Azure Boards till Azure Pipelines and Repos, all of these tools, all of these features basically enable the communication, and we're going to go through those one by one. So the first one on the Azure DevOps platform is Azure Boards. This is kind of where everything starts, because before you start developing the product, before you start coding and then it gets tested and released, you need to define what is it that you're developing, and more importantly, why are you developing it in the first place, right? What is the business value? What is the purpose behind that? So this is where it all starts. And you need a place to, first of all, document and kind of formulate those business values and make it transparent for the whole team what we're developing. So Azure Boards is the place where you basically get the transparent overview of what we're developing and what status each feature or each bug fix or each part of the development of the application is in, where everyone can just look at it and in addition to that transparent view, can collaborate on those. So let's actually see that in action.
Now we're going to dig into the meat and potatoes of Azure DevOps. So Nana told us about Azure Boards. So what we want to do is we want to get started with a new project. When we build out Azure DevOps, we have something called an organization. Your organization is the top level of what you're doing. I have an organization here. It's called Cloud AE Edwards. And I have built a project called ADO Demo. This is the demo that we're going to be working from today. As soon as I open up my project, you can see I have a summary page here. I have a little bit about this project. We can see what languages my code's written in. We can see a little bit of an introduction, and we can link here to our README for the project. We also have over here some project stats. We can look at work items created on the right-hand side. We can also look at our repositories with pull requests, commits, and also our pipelines. What are our pipelines doing? Are they successful? We can also see the members of the team that are in this project. So when we start a new project, we need to configure some settings. So let's go over to the project settings. So every project needs a name. A description is also probably a pretty good place to go. In this project, I've created an agile process. You can also do Scrum. You can do a basic process. It changes the features that are enabled in Azure DevOps when you do this. We can see the project administrators here are both myself and Nana, and we can see the services that we've enabled. We're going to go through each and every one of services that Nana introduced: boards, repos, pipelines, test plans, and artifacts. We can also look at our team configuration in the project settings. I've only created one team for this project just to keep it simple. But when you create these teams, you want to create groups. You might have contributors in your team. And when you think about the teams that you want to create, think about the characters that are involved. When we look at a DevOps any project where we have DevOps mentality behind it, we're going to need people like PMs and product owners and engineers. We need all these people involved in the project so they can all have different levels of visibility in the project. Now, every customer wants to know, how is their data secured? How is this access secured? Azure DevOps is hosted on the Microsoft platform, and it uses Active Directory as the backbone. So if your organization is using Active Directory for authentication, you can bring in your groups, your authentication groups into Azure DevOps as well, and create that security across the platform. You could also add people individually outside of your organization. So Nan and I are collaborating on this together. So we're going to be in the same team. The other thing we do is configure notifications for the project. So how do you want to be notified that something's happening? We can also talk about pull requests, who they go to, who does it notify, different teams. So if you have PMs or product owners that need to be aware of what's going on, they can get access to certain things. We also can configure service hooks so we can access different services outside of Azure DevOps itself and create subscriptions. We also can configure our dashboards. We're going to go over those in more detail in a bit. So first off, we're going to talk about Azure Boards today. So we need to configure our project. I've created the project, and in each project, we have something called iterations. I've called this iteration ADO demo, but an iteration could be a specific epic or big part of a project, and you call it an iteration. Then you want to set up below it the sprints. I've called mine sprints 1, 2, and 3, and you can also see I've selected dates. Each of those sprints are 2 weeks long, which is how our team wants to work, and every team works differently. Some teams work in 1-week sprints, some teams work in 3-week sprints, and some even work in 4-week sprints. This is a great way to create the sprint dates that work for you. The other thing you can create in your project configuration are areas. So we're going to go through areas a little bit more in depth when creating tasks. When I create my tasks, I want it under Azure DevOps Demo, and I have apps, and I have also a testing capability under my apps. I've also put in an infra bit to separate just the tasks, because some of the infra tasks might be related around infrastructure as code and not the app directly. Now, this won't affect how the pipelines run or our code. It just gives me some tagging preferences when I'm configuring my boards. Again, just for some visibility. Then there's also the team configuration that we can go through. So some teams don't use epics. Some teams only use features and stories. Some teams have different working days. A lot of people work Tuesday to Saturday, and they don't work Monday to Sunday. So you can configure the working days that work best for your team. The other really cool thing with Azure DevOps we're not going to talk about today is you can connect in your GitHub to Azure Boards. Azure Boards is a really mature project for literally tracking everything in your project and giving that visibility. So if your code is already sitting in GitHub in a repository, you can connect that through. You can also configure all the details for your pipelines, things such as agent pools. And what are agent pools? Well, agents, Nana's going to go into in more detail, but they're going to run our pipelines effectively. We can do self-hosted agents, but we're going to use cloud-hosted runners today. We can also go down all different settings in our pipelines and configuration. So it's really good to have a good look at these as you're setting up your project as your default before you get too stuck in at everything going forward. So now let's have a look at Azure Boards. We're going to start with the first top item. It's called work items. This is a little bit like a messy playground. It literally shows you all the work items that are in this project. And this can be a little bit overwhelming. So there's a couple things we can do to make it a little bit easier to read. I currently have it selected to see my activity. Now, these are items I've created, I've inputted, or I'm tagged in. I can also look at the ones that are just assigned to me, potentially. I can also look at the ones that are just assigned to Nana, or recently updated, recently completed, or even recently created. I can also create a new work item. So what are work items? There's several different types. So first off, we can create bugs. Bugs in our project are any issues or any technical problems that we encounter in our project or with a technology. So we'll file something as a bug. We also have epics enabled. Epics are going to be our big milestones in our project against our deliverables. And then within an epic, we have a feature. Our features are the things that we're delivering within those sprint cycles. Our features are then going to be broken down into these user stories here, and then each user story will have a task, and I will show you more shortly. We also have the capability to file an issue and a test case. So we can kind of create any one of these work items from this screen. This shows us all the ones that are available to us, and then they will literally populate right here. But like I said, this is a little bit messy, so we're not going to get into that just yet. We'll create work items shortly. The other thing we're going to look at is how we want to configure this. And this is what I really love about Azure DevOps, column options, because that column option may not work for everyone. I do want to see the ID of a task because as we look at this further and we start deploying stuff in a few minutes, I want to know what the ID is. The ID is also going to allow me to use traceability end to end in my DevOps lifecycle. I need to know the title and who these tasks are assigned to and all these other things, but I can add a column here. I can also delete a column. I have a ton of options here. As you're going to see when we go through all the different options and configuration, there are endless opportunities to really customize this that works best for you and your organization and the project you're working on. Now, we are using an existing Azure board as we've set it up. We've set it up for this project, but let's say you're going net new project, groundbreaking, you can import work items. This will take us to the query board, and we can actually choose a CSV and upload it. Now, I don't have a CSV with existing work items, but if you're migrating from maybe another platform or another tool, or you've used a spreadsheet in the past, this is a great opportunity to import them and start your boards in a much easier way. So that's Azure work items in a nutshell. That's pretty much everything you need to know in this. We can have a visibility of it, but it doesn't tend to be the areas we really, really want to work in. So the next part in Azure Boards we're going to look at is boards. So go figure, boards and boards. So Azure Boards is the Kanban style board that I spend a lot of my time working in. This is probably the second most important place for me to work. And it's because I can see everything of what's a new item, what's in progress, what's in review, and then what's being done. Now, I have actually created this board that suits me. So I can go into the settings, and again, we can configure how we want this board to look. So let's look at the cards. Each of those items are called cards. We can decide if we want to show the ID of the task, which I do because, again, we use that as an identifier in this project. I can show story points, and I can show tags, and we're going to go over tags in more detail shortly. I can also configure the style of what our cards look like. So we can create a styling rule. So lots of people like colors. It helps us differentiate what is going on. As you kind of saw with our work items, some of them are different colors because they all use a different icon, and that's really great. But sometimes as humans, we miss stuff. So maybe I'm looking to instate a rule for bugs. I'm going to enable this rule, and I'm going to give the card a color, maybe bright orange, okay? And I can say in the field that if it's a bug, or actually we use what's called a tag, we can give it that value of bug, save it and close it and see what happens. Yikes, that is bright orange. Now that's offensive to my eyes, but some people love it. But for me, if you start using a lot of these different styles, it's really hard for me to actually see what's going on. So I'm going to go ahead and remove that style just because I don't really love it. Because again, we could use another one where we get blocked items, right? And we make it bright red. You could also potentially choose a less bright color. Because again, if we enable this red color, it's going to be pretty harsh. Let's see what it looks like. And there we go. So we can see I've used a tag block, which we'll go over in a second. And that color just makes it hard to miss, but not really great to look at continuously. So what I do want to use is a tag color. So every single work item that we create should have a tag on it. So I have created one already for bugs, but I want to go ahead and add another one. I have a tag called blocked. So if we're blocked on a task or a work item, I want to go ahead and actually, I do want to make that red. Actually, let's make it green, even though, let's make it blue. So we can see here, I'm blocked on this item, and it circles the tag blocked with the blue, and our bug over here that's already enabled is pink. This makes us really easy to differentiate when we're seeing a blocked item or a bug, and I can see this in this Kanban style board. So the other thing we can look at is annotation. So we use these, again, these little visualizations to help people identify these tasks. We can disable them if really they don't work for us. We can also put tests into these tasks from here and create test plans. But we're going to go into test plans in a little bit further detail later on. Now, maybe I want to configure my board. So I told you this Kanban board is completely customizable. For what we're doing today, I really like having a new, an in progress, an in review, and a blocked and a done column. But we could absolutely put a column in, again, for bugs. You'll see a theme today. And I could go ahead and put that bug column in, and I might be able to put it, oops, sorry, I've overwritten myself. So a new column, there we go, bugs or bug. We can have a bug column. The other thing we can do is we can have a work in progress limit. So I could have a work in progress limit of 5 items in this column. Why is that helpful? Because if we build up too many bugs, we probably have other issues to tackle. We might have too much technical debt and problems in the application or in our project that we need to stop and assess. So this stops me from adding way too many bugs in the project. The other thing we can do is split this column into doing and done. So we can actually give subcolumns to the big column if that's what works for you and your organization. I'm going to go ahead and take the bugs out. Now, we notice we're using swim lanes. I love swim lanes. Now, I have a default lane, just one swim lane, but I could potentially create a new swim lane here and maybe we'll call it infrastructure. So we could have maybe an infra swim lane and an app swim lane, and let's see what that looks like. So it creates a little lane on top here, and we could make this lane below the application. So maybe anything that is infrastructure goes into here, and we can move it into the in progress under the infra swim lane. It's a good way to delineate and give you more detail into what's going on into your project. The other thing we can do is reorder cards. So every time I move one of our work items over, it changes the column and it actually reflects in our backlog into the priority. And we can turn that off. So it's entirely up to you and your organization what works best. Status badges. These are great. You can embed these into your documentation, into your wiki, into the front page of your overview of your summary of your project to know what's going on. It gives someone a quick view, even on a dashboard, what's in progress, what's in review, and what's blocked. Literally a quick working overview. And then the general bit here covers off the working days and stuff that we saw previously. All right, so I've showed you how to configure this Kanban board. Now, we're working in one project, but the reality is a lot of people work in multiple projects. So if I go up here, I can see all the teams that I have access to. Now I only have access to one team right now, but we can create multiple teams. So maybe you want to divide your teams up into your infrastructure, your development team, or really it's good to do application stacks or projects within a project, if that makes sense, into the different teams that might be working or specializing on something in that project. So that's something we can do. So, and I can also create new work items from here. So the work items tab above was really messy, right? But actually we can create a work item from here. We can create a user story. We can create a bug. I want to go ahead and create a new user story. I want to actually create a change in our website. And when I create that, it puts it in a state of new and it doesn't really have much other information. So let's look at what a user story looks like. So I've put a change in website here. I'm actually going to assign this to Nana. Nana is going to use this as her working task today, and it's going to go in a state of new. Now we saw this area that we created earlier in our project setup. This is going to be into our app area because we're not really deploying any, well, we are going to deploy some infrastructure, but this is mainly retaining to the app. And then iteration space here, we have the option of choosing the sprints. I'm going to choose sprint 1 because that's the one we're currently in with our working dates. I can also prioritize this. I want to give this a #1 priority, and I can go ahead and add a description. So I've told Nana I want her to change the website, and I can also add in acceptance criteria. So I can add that all in. She has that as a note, and it's been assigned to her. We can also do things like add a pull request or a branch, but Nana's going to go ahead and show us how to do that later, and she can link to this work item or any other work item that pertains to her task. The other thing I can do is add related work. So I can add an existing item that actually might already be in our repository somewhere. I can search for other items. So I can see that we've had other user stories and other things going on. I don't actually see anything that really pertains to what we're doing, but I might actually just need to create a new work item. So I want to create a new work item for Nana, and I'm going to call it inspect current configuration. And I've given her a child task. And we can save and close that. We also have an analytics tag under boards. So we have a cumulative flow diagram that gives us a full report of average work per person that's in progress. So right now, this is showing the last 14 days. I can go back to 30 days or 60 days or even 180 days or do a custom rolling period. If I have more than one swim lane enabled, like I looked at the infra one, we could enable that. I can also look at how many items are done. And so I can see the work items in progress over the last couple days, really, but I can set this and get some analytics from that. I can also look at the team velocity. Now, we already know we don't have a velocity in our team yet. We have 2 work items in this sprint that, well, 2 that are incomplete and 1 that is completed. So we absolutely have a lot more work to see. So now that we've looked at the Kanban style board, let's go into backlogs. So why are backlogs important? Well, we want to talk about the process of DevOps and coming together. We need to think about the ceremonies we run as a high-performing DevOps organization or one that's just getting started. we want to look at how we do our ceremonies. So for organizations that don't do ceremonies, this is something you need to think about. Whether you're running sprint planning or backlog grooming, this backlog piece is where you'll spend your time for a lot of those meetings and those planning calls. We need to plan what we're going to do in the next sprint based off how we were successful, what we achieved, and what we didn't achieve on the current sprint. So again, we have it set up here where we can see all of the user stories, tasks, and bugs aligned to this sprint. How do I know it's in this sprint? Because it tells me we're in the current sprint right here. Also, all the iteration path are for these in sprint 1, and we can see where things are aligned to sprint 2 and sprint 3. So this literally gives us our entire backlog for the project. And again, you have the ability here to access other teams. You can create a new work item from here, the same as we did before. We can create new website, add it to the top, and we can do all sorts of things with that. So we can also create that work item from here. When I create that work item, I can click on this and I can edit it because really it's not assigned to anyone, doesn't have any details in it. We need to think about doing that. The other thing we can do is we can do work item templates so that maybe if we automate a lot of our processes, maybe when something fails, it creates a work item, etc. We can create that template to do that. The other thing we can do in that work item is add an existing task or add a new task here. The other thing we can do is we can move this work item to an iteration. So if I move it to the backlog, we see up here, it's in the ADO demo iteration path, and it's actually not assigned to a sprint. So it's not uncommon to have a lot of items here in your backlog. I can go back and move it to an iteration, maybe sprint 3, because that's where it fits in what we're trying to do. You can also move the position. So maybe I want to move this down to position 7 because it's not really a high valued work item at the moment, and we can deal with it later. So there's all sorts of things we can do. We can change the type of the work item. We can move it to a team project. We can also create a new branch from here. So we have lots of options when we're doing our backlog and sprint planning ceremonies. We can see on the right hand side over here that we have the planning tool that we have pretty easy to see. We've got the team backlog, and you can see we have the current sprint. We have a good visual in seeing how many user stories are there, how many bugs we have in this current sprint, and how many user tasks. We can also see the working days, the dates of the sprint. We can go ahead and create a new sprint. I can give start and end dates. Now, Azure DevOps is really intelligent. It sees that we've been working 10 working days, i.e. 2 weeks, and it gives us that ability to add that in. So I want to add it to the existing ADO demo. It's going to give us sprint 4. Now we have a sprint 4 that will be listed into our backlogs that we can add tasks to. So same as the previous boards that we had access to, we can configure those columns. So we have the work item type, the title, the state, the iteration path. Maybe we want to add another column that works best for our organization. So maybe we want to look at risk or something else when we're looking at our planning. That could be a really good thing to look at. I'm going to actually add severity down. And we're going to add that in. So I can see the severity. We have a couple of these that are a 3 priority. We might want to move them up in our sprint cycle. So the next thing we can do is look at analytics of our sprint. Again, we still get that same cumulative flow diagram, and we can see the sprint burn down. Next item we're going to go to is the sprints feature in Boards. This is absolutely where I spend most of my time. It is the easiest for me to read. I get full visibility of everything going on in Azure Boards. This is a great place for PMs, your project managers, to see what's going on. And it's great for you as an engineer to create these tasks. Any kind of product owner that wants visibility into the product can also see how much work is going on. This is where we drive value to our organization. When we work for organizations and they tell us, oh, you're not driving enough value, or what are you doing with your time? This traceability helps give them that. That gives us an exact insight into what work we're delivering and how we're delivering it. So here we can see that we have a couple tasks on the board and, we have a few tasks under each user story, and we have a bug. So this breaks it down for how we can see it. And again, we can configure this to make this fit our needs as an organization. So we can add in tasks, bugs, and user stories. We can configure how we want those to show. And again, we have styles. So we can add that styling rule that if we want to make something bright green or bright blue or light green, if chance may be, we can add those styles in there as well. So each of these items in Azure Boards gives you that full ability to configure it. So we're actually going to make some changes to our website today. That's what we're here to do. So we can see that I've actually put in some document changes for our website. I've also made I want to make some other changes to our website, and I've assigned some tasks. I'm going to go ahead and assign this task here to Nana. So we can estimate how much time it's going to take. I'm just going to put an estimate for her. There are still all the 4 hours remaining and nothing's been completed. We can also customize these effort hours by using plugins and other things if that doesn't work for you and your organization. But one thing we need to do here is add a tag. So we're not doing documentation. We are doing some application deploy. So I'm going to tag it with app. There's nothing else we really need to tag it with, but we have some suggestions here. We can add it to that. We can also add website in as a tag. And again, we can use these tags for traceability. So I'm going to go ahead and save those changes. So this is Nana's task. We can see that there's a 4 next to it. That is our amount of effort. We can also see the tags down here. And again, we can use the style to make them look a little bit nicer. Now here's where the sprints board gets really exciting. We can see the sprint 1 up here. We can also see sprints 2, 3, and 4. We can see they're in the future. So we can also look at previous sprints. We can look at how our work burn down rate was. We can see what was successful and what wasn't. I can also hook into the backlog here and see what's the backlog for this specific sprint. It's a lot neater than just the backlog board. And I can also see the other backlogs. I can click into those and drill down into those. Also, what's really good to see is capacity. Now, why is this really important? Let's say I'm going to take some time off, or there's a bank holiday coming off. We can put in team days off. So that means that that 2-week sprint cycle actually gets chopped down a little bit more. If I have some personal holiday coming up, I can go ahead and log that. I'm going to put in here that I have 6 hours of capacity each day, and I might be working on development of this project, and I'm going to go ahead and save that. We can also look at analytics based off the sprint. Now, unfortunately, our burn down trend is not so great, but we're going to fix that today. We can see how many tasks we've completed, what our average burn down rate is, and what our user stories look like. So it's a little bit embarrassing, but we're going to fix that. The other cool thing we can do is we can run queries. Now, if you were paying attention to all the other all the other tabs in Azure Boards, they all had the query option to run a query based off of what you're doing. We're going to go into queries and look at what queries can do. So we can save queries, and this is the results. So I've run a query already, and it will pull up these results. I'm looking at any type of work item that has been assigned to me. I can see them here. And we have all sorts of ways we can use this. I can also look at the editor here. So I can see that I can add things to my query and change my query. But right now I just want to look at what's assigned to me. The other cool thing is I can add a chart. We can do a pie chart. I like a pie chart. And we can do the state of everything. And we can see here that it generates a pie chart so I can see it. Now I can pin this to one of our dashboards. I can also share this with the wider team. Sometimes you might want to look at the team burn down or the tasks in progress. This is a really good way to see this, and it updates it pretty regularly. So I can see that I have 6 active tasks, 2 are in progress, 7 are new, and 5 are in the design phase still. So I need to really think about how I allocate my time, but I can use this to query know what's going on in Azure Boards. The next thing I want to talk about are delivery plans. Delivery plans are really, really cool. Delivery plans are a feature of Azure Boards that are fairly new to Azure DevOps as part of like a full-time feature. They allow you to review the schedule of your stories and feature that your teams are working on and use that selected view against your teams against a calendar view. This is really helpful when you're managing several projects and a team. So when people come to us and say, well, I'm managing so many projects and so many teams, how do I get that visibility? Delivery plans are the way forward. You can add up to 15 team backlogs, including a mix of backlogs and teams from different projects, as long as they're all under the same organization. You can add a custom portfolio of backlogs and epics. You can view work items that span several iterations, and you can reset start and date and target times through drag and drop borders. And you can add backlog items. So I've created one for agile features. And if we go to the calendar here, we can see the features in our project and how they align to each sprint. So this is really great. I can then add another delivery plan for another project or a different view of the project. Maybe I want to look at work items versus the features and compare the two. But this gives me a great overview of what's upcoming in our sprints and how we're doing. And this helps me create a delivery plan and how we're delivering against our features and our epics in the customer projects. The next thing I want to go into is retrospectives. Again, this is going to be part of our ceremonies as engineers. Retrospectives are really important to run after every single sprint, and it's built into Azure DevOps. So it gives us the ability to say what we did well, what didn't go well, and what we could improve upon. So let's go ahead and create a new retrospective. So I'm just going to call it Retro 3. We can do all sorts of things like make feedback anonymous. There are many times when we want to make a retro anonymous if there's a lot of maybe emotional decisions that were made in a sprint, or maybe that's just how the team operates, and that's okay. The other thing we can do is select a template of how to run our retro. So we could do things like mad, sad, and glad, or what can we keep, add, do less of, or maybe do more of. So we can add this into our retros. And I can go ahead and look at the old retros. I can look at the upcoming ones, etc. And we can collect this information here. We group the information, and then we can vote, and then we can act. When we put this all in together, we can do a lot with this data. We can send this data off. We can export as a CSV. Again, this is where you might want to have a retrospective that is anonymous. You can also send an email to the team to remind them, hey, we have this retro today. Going to the next sprint, this might be really helpful. The other thing you can do is do a show retrospective summary of all the retrospectives you had and that existing one to know what actually happened and have that traceability. So the next thing we're going to go into, I talked about this ability to pin things to dashboards and create all this visibility in Azure Boards. I've already created a dashboard here with some really helpful features for me. So the first thing in this dashboard is I can see our build pipelines. I can see what's failed, what's been successful, and how many builds ran and when. This gives me a really good visibility into kind of the overall health of my build pipelines and my release pipelines. I can also see the team here. We have 6 days remaining in our sprint. I can see how many work items aren't started. And maybe I need to, as a PM, go to my engineers and say, we need to reassess what we're trying to deliver and maybe move things to another sprint or to the backlog or bring in extra help sometimes. Again, we have this visibility, and I can see this burn down rate right here. And I can also configure a query to run on this dashboard. You can literally configure this dashboard with any of the built-in widgets that are here that suit you as an organization. So that's pretty much Azure Boards. And a couple of things to note, you can do all sorts of things that hook into Azure DevOps. So you can use Power Apps to help automate task creation in Azure DevOps itself, maybe based off an event or a risk or something else. You can also hook in to third-party communication tools. You can also hook into Microsoft Teams. So anytime a workday item is aligned, you can update it in Boards, and it will then update into Teams to communicate with the team. So we want to break down those silos, enable everyone to work better, and stay organized. So Azure Boards is literally this huge encompassing tool that gives the PMs the visibility to know what's going on. The engineers can create their tasks, can create their work items, and we can have visibility of how the sprint's going and where it is going to. And we can track everything from beginning to end. So that is Boards in a very big nutshell. When we were talking about Azure Boards, we talked about extensions that you could hook into Azure DevOps. There are so many different extensions that you can use. Again, we talk about communication, breaking down those silos in our organization. Now, think of that scenario when maybe there's been an outage in your organization or you're trying to get a feature out the door and someone comes and taps on your shoulder and goes, hey, I want an update. What's going on with the project? By opening up communication to wider teams, we can create that communication, open that up, and not have to have someone tapping on your shoulder. Hopefully, I can't make promises. But we do have Azure Boards capability here that hook into Slack. So it sends the notifications into Slack. And we also have it here for Azure Boards into Microsoft Teams. Now, as we start talking about the other features, there are ways to hook in Azure Pipelines into Teams. So you get updates on when your pipelines are building and when they're successful or when they hit maybe manual intervention. But there are tons and tons of extensions for Azure DevOps. So take a look at the marketplace and look and see if any of the extensions are right for you and your team. Now we're going to talk about Azure Repos as it sits in Azure DevOps. This is really just our source control system, and it uses Git on the back end. It also uses Team Foundation version control if you want to use a centralized version control, but it allows you to search your code, create a pull request, and put some branches in there. Now, Nana's going to walk us through all the technical parts of it, but I just want to cover off a couple items. With Azure Repos, it does handle Git, but it holds your code in a secure location, basically on the Azure backplane in the location in which your Azure tenant is located. So for instance, Nan and I both sit, well, she sits in Europe. I technically don't sit in Europe anymore, but I do, but I don't. But I sit in the UK, right? So we're in Europe, but we're really not. So for data residency, our data needs to sit in the UK. For Nana's purpose, her data needs to sit in Europe, and she doesn't want it in the US or somewhere else. So this is a really big sell for Azure Repos. Why? Because of data residency. And so many organizations are required to have this for compliance, obviously, and in a lot of their contracts when they're delivering software. So Nana, take it away with Azure Repos.
So once you create those boards and once you have set up those tasks, and you basically start the sprint, and you have a bunch of bug fix tasks and feature tasks on that board, you have to implement those, right? And for that, you have those Azure repos, and this is where your code lives. And as April mentioned, it's basically Git-based, so you have all the features that you have available in Git, which means you have all the branching features, the pull requests, and so on. And so basically, your team, your project team may have may be working with different Git workflows, right? And this can vary between the projects, between the teams. So whatever Git workflow you are working with in your team, you can implement with the Azure Repos feature, because this basically just gives you the tools and allows you to implement that here on the platform level. So basically, in this case, let's take an example, and let's say we have a team that works with feature branches, and for every task or bug fix or feature, whatever it is, we basically create a branch, right? So if I go to the branches, right now we just have one main one, and we can create a new branch based off that feature branch, that main branch, and let's call this actually feature/website change. And you can actually link that feature to the work items that you created. So this is the task or user story that I'm going to link it with, change in the website, and I'm going to create that feature branch. So now you see the connection and the advantage of having one platform for all these different workflows and all these different tasks, because I have the boards here as well, and I have the repos on the same platform, I can actually have connections between those, and I can have backlinks, and from boards I can connect to jump into the feature, and vice versa. So this is actually something that makes the workflow very efficient. So as you see here, we have a feature folder, and then that's the name of our feature branch. And if I go inside, I see that feature branch's view of the files, and in the file section, you have the list of the files in your code. So let's say if I go to the source and jump into the index.html, and by the way, you can edit the files here as well on the browser view. So if I go to edit, and let's change something in the index.html. Let's say this is our Azure DevOps demo website. And let's say I want this to be the change. So I'm going to commit that, and this is going to go to the feature branch. So we're not doing anything or making any changes in the main branch. And I'm going to commit that. And let's say I have worked on this for a couple of hours, and now this is in the state where I want to merge it back to the main, right? I want to make it part of the deployable application version, so to say, and the end result or end goal of any feature development or change is to release it to the end users, right? So I want to release it, and before or instead of just throwing it to the main branch, we want to make sure that the changes we have made in the feature branch are actually releasable, right? The code quality is correct, or code quality is fine. Basically, we haven't broken anything else. Especially if you have maybe junior developers, you don't want people just be pushing stuff to the main branch, right? And for that, the main feature, and you probably know this from maybe other repository platforms like GitHub or GitLab, we have pull requests or merge requests. So if I go to the pull requests right now, we don't have any, but you can create pull requests from the feature branch to merge it into the main branch. So let's actually do that right now. I'm gonna click on that, You can adjust all this data like title, description, whatever. You can add the reviewers. So again, a use case would be, let's say you made some changes and there is someone in the team who is either more knowledgeable in that specific code section or in that specific feature, like knows a little bit more technical details. So you can add them as reviewers or maybe senior engineers, and they can review your code and basically decide, okay, this can be approved, like this, the code quality is fine, and this can be merged back to the main branch. So let's actually create our feature, our pull request. And now those people that you have, and I haven't added any reviewers, so let's actually add the reviewer. So now once April sees my my pull request, she can look through the code. She can see what changes I have made, what updates, the commits, so she can have all this information in view here. And if she, let's say, decides, okay, this is actually not quite the standard, or something is missing, or the code quality isn't right, or whatever, she can actually add comments and feedback to basically, and this is kind of way of sharing know-how and knowledge between the team. So you can give feedback and teach people who have developed this, hey, by the way, this is not really correct. The next time, like, or this is our standard when coding, so let's do it this way, right? So you can add something here. In this case, it's me, so I'm gonna add some comment like this is the way I thought of greeting. Oh, it's fine. So basically, you can communicate within those pull requests, and that's also, again, going back to the collaboration and communication between the teams. You have all that communication tooling like kind of merged inside those features as well. So now if April, awesome. So if she approves the pull request, then it can be merged into the main branch. Okay, so I have a message that says, can we change the name, please? Awesome. So once April has approved the pull request, I can actually complete the pull request, meaning I can merge it back into the main. So let's do that. There you go. And you see that the pull request is merging. And we have no pull request open. And if I go back to the files and I'm in the main branch, we're going to see that change that we did that I did in the index.html file right here. So this is basically how you can use the Azure Repos. As April mentioned, the code is actually securely stored as well on the Azure cloud, and you can use all these features. Obviously, if you're not going to be mostly you're going to be working from your local machine with the code editor, but you have all these features for nice visibility, as well as probably the most important one being the pull request for the communication and really enforcing the code quality in the projects.
Thank you, Nana, for covering off Azure Repos. We're starting to see how the different facets of Azure DevOps are coming together. Now we're going to hit off Azure Pipelines. This is the CI/CD tool for Azure DevOps, and this is what a lot of you have used potentially before, and hopefully you're going to continue to use. So Azure Pipelines are really cool. You can literally deploy to any location. You can deploy to on-prem, any cloud, whether that's Azure, AWS, or GCP. Especially if you're using a hybrid environment, you can deploy to both your environments at the exact same time. The other thing you can do is test on Linux, Mac, and Windows runners, so you can deploy against literally any operating system for any app. You can stage your environment releases. You can do deployment methodologies where you have automated deployments or maybe even manual deployment approvals. But we're going to go through this step by step, and Anna's going to run with us and show us everything about Azure Pipelines.
So now we've come to the Azure DevOps feature, which is my favorite. and these are the pipelines. So once we have created those boards, once we have implemented those features, obviously we want to deliver that code change or that feature or bug fix, whatever we implemented, all the way to the end user, right? So we want to basically create processes or create a streamlined process that takes our code changes, it tests it, it makes sure that we have no security vulnerabilities and issues in our code or in our artifact. It then deploys it to the environment, but we don't want to deploy directly to the production, right? We want to deploy in stages. So we deploy to the development stage, we do some more extensive testing, and we deploy to the next stage, do some more extensive testing, and then go all the way to the production environment where the end users can now see those code changes, use that feature, or benefit from that bug fix. So this is what we're going to build in this section. So we're going to go from having no pipeline. So if we go to the repository code, we have no pipeline yet. So we're going to start from scratch. This is the previous run. So we're going to build a pipeline step by step. We're going to start with the CI section. So first, we're going to build the part of the pipeline that takes our code changes and packages it into a Docker image, and then also scans that image to make sure we don't have security vulnerabilities. And once we have that image artifact, we're going to take that and deploy to the production in stages, right? Development, testing, and production stages. So let's start with that. The first thing we do to create a pipeline is the simplest step, which is create the file called Azure Pipelines.yaml. And this is the name itself is a trigger for Azure DevOps to recognize that we're creating a pipeline file. So it knows to trigger the pipeline immediately. So I'm going to create actually an empty pipeline code, pipeline file. And I'm going to commit this directly to the main branch, actually. And I showed you previously that we have this edit view here with basically just some browser editor. But what we're going to do is we're going to actually edit our pipelines.yaml file and write the whole pipeline from the pipeline section. So I'm going to click here and to edit. And we're going to start here from scratch, and you see the same edit view here, but we have something very interesting on the right side, which is the tasks. So this is basically the list of already prepared packages of code that we can add into our pipeline that do those tasks. For example, building a Docker image, pushing the Docker image, deploying to a server, deploying to Azure web application, and so on. So these tasks are actually going to help us and take a lot of work off from us. So instead of us just going there and scripting different Linux commands, we're going to use those tasks that we can parameterize and pass parameters to build our pipeline. So first of all, let's do the first things first, and I'm going to define the trigger. The trigger is very simply just what triggers this pipeline, right? In our case, we're going to say that any changes in the main branch will trigger the pipeline. And this is, again, we don't need any webhooks here. Whenever something changes in the repository, this pipeline, whatever we're going to define here later, will trigger immediately. The second thing we're going to define is something called a pull. And pull is basically where the pipeline tasks will be executed. So we're going to define a VM image. And this is something that April mentioned as well at the beginning of this video, where the pipeline, the task that we define, right, building the Docker image, pushing it to the repository or deploying somewhere, it has to run somewhere, right? We need some kind of environment, a machine that will execute those tasks. And very conveniently, when you're actually starting with Azure DevOps and with the pipelines, you don't want to go through the trouble of setting up your own servers and agents and connecting that to the pipeline and then having that server or machine available for executing the tasks. So conveniently, actually, with Azure Pipelines, you have some servers already available, so a pool of servers available that will execute your tasks. And as April mentioned, they're running on Azure Cloud. And this is what we're going to leverage here. So we don't have to go through the effort of setting up anything at the beginning. What we're going to define here is what kind of machine and what kind of operating system we want to execute those pipeline tasks. In our case, let's choose the most simple Ubuntu latest operating system distribution. And now we're going to know that our pipeline tasks will be executed on a machine which has Ubuntu latest installed on it, which means we can execute any Linux scripts, Linux commands in our pipeline. Awesome. So now let's actually start defining the different parts or stages of our pipeline. And stages is kind of the hierarchically the uppermost level that lets us define what stages we're going to have in the pipeline, what steps we're going to take in the pipeline to take our code changes and kind of walk that through the testing, the building, packaging, and so on. So the first stage is going to be building the application. And this is going to produce the application artifact, which is going to be Docker image, which has already become kind of a standard in the industry. So that's what we're going to be building. And within the stage, we have multiple jobs, right? One or more jobs. And these jobs are the ones, let me say. So let's define the first job that is going to build and also push the image. And we're going to see the code for that in a second. So build, push, image. And in order to execute the job, we have multiple steps. So this is basically the hierarchy of defining your jobs, different tasks or steps of the pipeline. Once you have that structure, basically you're good to go. We can then fill out the rest of the stuff. So now we've come to the point where we have to define the task. And task is like the basic building block of the pipeline. This is the smallest unit. And this is, just to give you an idea, task is like Docker build, right? So building a Docker image is a task. Pushing a Docker image is a task, right? So a small unit of work, like one small step in the pipeline is a task. So let's actually define that. But as I said, we don't have to script it out ourselves with some Linux commands. We can use existing tasks, which should actually make this easier for us. So in the tasks, first of all, you have a long list of those, but we can search for Docker. And let's see what we have available. We have a couple of those. I'm going to choose the Docker one. And you can actually choose different commands, like you can do Docker login from here, Docker start, whatever, and you have build and push together, which kind of makes sense because you want to do those steps usually in the pipeline and makes sense to put them together. So we have the build and push command selected here. Another thing we need to, in order to build a Docker image, is obviously a Docker file, and we actually have that already. It's a super simple Docker file that just takes our application, copies it into the image, and then starts it with an entry point script. And the rest of the stuff, let's actually fill those out. The first thing we have is whenever we're pushing the image, so once we build the image using the Docker file, we have to push that to the repository, right? This is going to be a private repository because we don't want to share our images with everyone. And that private repository needs to be authenticated with, right? So our pipeline needs to knock on the registry or repository door and say, please let me authenticate and let me push this image and kind of leave it here, right? So we need to authenticate with our Docker private registry. So for that, we have the field here, which says container registry. So this one actually will be the connection to that registry. And the second one is going to be container repository. So this is just to give you the differentiation, what the difference between registry and repository is. Registry is the service itself. So the Docker container or images storage service, like a GitHub or from Azure Container Registry. Different platforms have this available, from Nexus, for example. So the service itself, the platform that has this service available, is the registry. And for each application, you can actually create a repository. So when you're building the same application image, you're going to produce different tags. So basically, you have a repository for that specific application where you store the images of the same application with different tags. So in the company-wide registry, you may have multiple repositories for different applications, each one with their image tags, right? So that's the differentiation. And we need to provide both. Okay, so this is the repository that we're going to use. And as I said, we have to first connect to it because it is a private repository. So usually you would have some kind of Docker login command, and you would have to provide username and password credentials to log into the system. And we could absolutely do that. But in Azure DevOps, we actually have a better way of doing it. And this is actually a very interesting concept and really interesting feature, because this is super useful generally in the whole pipeline. Because when we're creating a pipeline, we are kind of orchestrating a lot of different things, right? We are connecting and integrating also with a lot of external platforms and services. One of them being a Docker registry. We're always going to need that. So we push the image to that registry. Another obvious one is whenever we are deploying, for example, our built artifact to an environment like a server, we need to connect and integrate with a cloud platform or on-premise, wherever that server is located. Maybe we're integrating with some test platform to send the reports of the tests or whatever. So we need a lot of different integrations with external tools. And for all of those, we actually have this feature in Azure DevOps called Service Connections. And this is actually something that allows us to integrate and connect to those external platforms. So if I go to the project settings, so right here, and in the service connections, this is where you can actually add new service connections, and this is a list of all the platforms that you can connect to, like Bitbucket. So if you are using code from a different source than the Azure code repository, like GitHub, Bitbucket, or whatever, you can actually connect to those. We have AWS for Terraform and lots of different other platforms that you may need integration in your pipeline, right? So in our case, we actually have gone ahead and prepared those service connections already. So we have this one, which is for Docker registry. And what service connection basically does is connects to that external platform, and without you having to store your username and password, just taking that account, connects to it, and now you can use that connection in any of your pipelines to push the images. So we don't have to do Docker login again. So moving back to our pipeline, right here, this is the service connection. So that's the name of our service connection here, ACR demo. This is the one we can very conveniently select here. And that's going to be our connection to the Docker registry. The second one here is the name of the repository itself. And in our case, our repository is called Azure demo .azurecr.io. And with these parameters, actually, and as I said, you can parameterize each task and provide and pass any parameters and different values. So for example, if you had Docker files somewhere else and you needed some other tag, you could configure all of that here. And once we're done with the configuration, and you have to pay attention and make sure you click on the right place. So right here, we want to add the task, and this is going to be automatically converted to YAML code, and that's what we end up with. So this is the task with inputs or parameters that we configured, and Docker task that basically under the hood does all these Docker build, Docker push commands, and whatever, takes all these parameters and will hopefully give us exactly what we want. In my case, I actually want to add the tag specifically. So let's add that as well. So it's kind of more transparent and clear. So there you go. This is exactly what we have configured. So what does this value actually stand for? Whenever you see something starting with $ and value within the brackets here, it is actually already available environment variable that Azure DevOps Pipeline gives you to use, right? So this specific one is the build ID. So every time the build ID will be different. So we're making sure that our images, every run of the pipeline will produce an image with a unique image tag, right? And you can actually find a list of all the available environment variables that you have available for your pipelines that you can actually use wherever you need. So this is the one we are using for the tag. And that is actually all we need to build and push our image using the Docker task. Now, another thing we want to do with our image, and this is what I mentioned quickly previously, is usually a good security practice, especially when you're building production-grade pipelines, is to always make sure your images do not have security issues, right? And there are tools actually that help you do image scanning. So what image scanning does is basically goes through the layers of the image. Because if you know, the Docker image, for example, is composed of layers. So it goes through every layer and it tries to find out if there are any known issues or vulnerabilities in the packages and libraries and tools that are inside those layers, and basically warn you about those. And if they are, then you get a kind of recommendation from this tool that says, use this version instead to fix that issue because that known vulnerability was actually fixed in that version. As a next stage, actually, in our pipeline, we're going to add image scanning. So we're going to actually add a task that pulls the results of image scanning from the Azure Container Registry. Now, and this is also a very important thing, and also an important reason why we're using Azure Container Registry in this case, is that Azure Container Registry actually has a tool called Microsoft Defender that it can integrate inside the registry that can do the automatic image scanning whenever we push the image to the registry, which is awesome and super convenient because as soon as the image lands in the registry, the scanning will be done and we will get the results in that registry. Now, in our pipeline, however, we don't know what those results are, right? So they're kind of sitting in the registry. So we have to explicitly pull those results of the scanning and see in the pipeline whether any vulnerabilities, any security issues were discovered. And if they were, obviously we want to break the pipeline because we don't want to release an image that has any known security issues. First, we want to fix that, and then maybe we can rerun the pipeline and release the image. So we're going to add that as a next stage here. That will go ahead and pull those image scanning results and give us the results in the pipeline. So let's actually call this scan image. And we have jobs and the job. Let's call this one, so scan image. And as you probably already thought, we're also going to use a task here. And this is how we're going to do the image scanning in our case. So I'm going to go here and open our code repository. And right here, we have basically a PowerShell script that is from the official Microsoft source that basically what it does inside is goes and queries the results from the Azure Container Registry and gives it back to the pipeline. And we're going to execute that PowerShell script. And for that, we're going to use a task called Azure CLI. So this is going to be just a simple task that is there to execute any scripts that you have. Okay, so just like any other task, we have to provide some parameters. Obviously, we want to tell our script where is that repository, which registry or repository it should connect to and get the results from, right? And which repository. So we're going to provide all these values here. First of all, we're going to choose the service connection to the Azure platform where we have our container registry. The second one is going to be the script type. So we're executing PowerShell. Then we have the script location, which is going to be the script path. You can also provide an inline script, so directly scripting it here. And let's actually provide the path. So we're going to take another environment variable that we have available from our pipelines, from Azure Pipelines itself, and kind of get injected here. And I'm going to take we have to provide an absolute path here. So we're going to do source directory. So this is the root directory of our project. And then inside the script folder, we have this scripts. And there you go. So this is the absolute path. And we have to provide arguments to the script that says basically which image registry we're connecting to, which repository we want to scan the image, and which image actually we want to scan. So what's the tag of that image? And I'm going to actually copy those arguments right here. Okay. So the registry name is ADO demo. So that's how the registry is called inside our Azure container registry. Then we have the repository parameter. And this is actually this value right here. And we have the tag. And we're going to obviously use the same value. So that's going to be the image that we want to scan, right? The last built and pushed image. Awesome. And now this is the error action preference. So we're going to say whenever, so we're going to say in case these errors basically want to stop the pipeline. So with this configuration, I'm going to put my marker back to under the steps, and I'm going to add the code. And there you go. We have the YAML representation of that task. Again, we are using Azure CLI task, and this is all the parameters that we have passed. And now with this configuration, we're going to be building and pushing our image, and afterwards the image will be scanned automatically in the Azure Container Registry. And with this stage, or with this task, we're actually pulling those results and fetching those results here if the results were unsatisfactory. So if we found some vulnerabilities, then we're going to fail the pipeline. So let's actually save this, which will, and I'm going to commit this directly to the main branch. And this will actually automatically trigger the pipeline, as we're going to see. So if I go to pipelines, there you go. You see the queued icon. And we have two stages, build app and scan image. And now our pipeline is in progress. So let's wait for this to finish, and let's see the results. So as you see, both stages were run, and we see that build app was actually successful. And if I click inside, we're going to see the logs of all the tasks that were executed within that job, within that stage, within that job. So these are actually a bunch of automatically injected tasks. So do not be surprised if you see a bunch of tasks here. And this is the one that we defined, the Docker one. And this is green, so it means our build and push command or task was successful, and we were able to actually push our image to the repository. And somewhere in the logs, we will also see the tag that was used to tag our image. This is the build number, which is 297. Later, we can check that we actually have that image tag in the repository. And the second one that you see actually failed, the scan image. So let's actually see what the issue is. And as you see, the logs are actually very handy when we are doing troubleshooting like this. So in the Azure CLI task logs, we can actually see the logs, and we can see the reason why it failed. In our case, it's because there was actually image vulnerability. So let's go actually back to our image repository and check all of that in more details from the Microsoft Defender, what their issue is.
So I'm logged into Azure portal and I'm in my container registry for this project. Now, the reason why we're using Azure Container Registry is because we want to enhance the security and have full traceability. So the first thing I want to do is look at why our image actually failed. So I'm going to go down to services, click on our repository, and click on the repository that we've connected to in Azure. Now I can see a list of all the images that Nana has pushed or I've pushed from our pipelines, and I can see the tag. Now, if you've been paying really close attention, we had tag number 297. So I can look at the tag here and go image tag 297. So I have full visibility into what's gone on. I can see everything that's gone on with the image, what's happening with it, and I can track that through and through. Now, the other thing we've done, because we want to create full traceability and visibility into our organization, we also need that security element. So this shows our container registry, but I actually want to go and look at why this failed. And the more detailed logs that we can get are actually going to help us. So I'm going to go into Microsoft Defender. The reason why we're using Microsoft Defender explicitly in this case is because it's multi-cloud. And if you've been paying attention, we're using Azure DevOps, which allows you to deploy to any cloud using any code or even on-prem, literally any platform. So we want to have that visibility end to end. So Microsoft Defender, yes, it is a Microsoft product, gives us visibility into Azure, AWS, and GCP. So we can look at our security posture across all those different organizations. We can also look at our regulatory compliance, workload protections, but we really, really want to focus on what's happening in our container scanning. So if I pull in our registry again, I can click on Microsoft Defender for Cloud, and we can see exactly what's going on with our registry. Now, we have a couple issues that we need to address. Two of them are networking issues, which we can add tasks for in our board, actually create a bug, and look to address it later in our sprint, depending on the severity. Now, we have a couple high severity items that I want to look at. The Azure Container Registry images have some vulnerabilities that it found, and they're quite high on the severity list. So it does list them out. We've had 2 issues with, it looks like security updates in our Linux images, and it looks like it applies to 37 of our 37 images. So it's probably a pretty good thing we need to create a task for and get a bug and give it a priority 1 for pretty quickly. But it tells us what version of Linux are affected by this. We can also see the severity. It is a vulnerability, gives it a score, and then we have remediation. So it gives us the patch that we need to apply to our images to do this, and also the fixed version that it applies to. So we can read up on potentially any other issues that image patching could cause. But it also gives us a list of every single one of our images that have this vulnerability. So the same will apply for the other one. So the other thing we can do to fix this is we can create the task, which is what we can do to move forward. But I'm going to hand this back over to Nana, and she's going to go ahead and take us forward with our pipelines.
Awesome. So let's go back to the pipeline. And as April mentioned, we actually did find an image vulnerability that in this case can be kind of handed back to the team, and we can make a bug fix task or kind of give it back to the team to fix it. In our case, let's actually take this part out, and we're going to continue with the next step or next stage of the pipeline, which is after building and pushing the image to the repository, we want to take that artifact and deploy it to the first stage or first environment. In our case, this is going to be a dev stage to basically make sure that our application is successfully deployed and it's working and we can access it from the browser and so on. So let's do this in this part, and I'm going to create a stage, as we already know. Let's actually call this deploy dev. Then we have jobs. And let's call the job as well, deploy dev. And again, we're gonna use or take advantage of a task here that will help us to deploy to Azure Web Deployment. So we can do Azure Web or Azure App Service Deploy. So this is a task that will basically let us connect to Azure platform and deploy our application or our image actually as a container to that environment. So Azure Resource Manager is the connection type. The Azure subscription is the one we've used already. So this is the Azure account basically that we're connecting to. And this is an important one because we have to decide what kind of service type we're using. In our case, we have a container that we want to deploy to, in our case, we can choose the Linux operating system. So we are deploying a web application as a container. So that's our service type. And we already actually prepared multiple services for different environments. So we have dev, test, and prod. And the first one will be dev. And this is where the service that we're deploying our containerized application to. Now, obviously, so this is the target environment where we are deploying our artifact, but we also have to tell the pipeline or the task where to get that artifact, right? So where to pull that image from. And this is, again, the registry or our container registry and repository name and tag for the image. So we are basically giving the address of that image, and let's fill out those details as well. And by the way, for more information, next to each parameter, you have this kind of full description of what kind of values are expected in each input field. So you can check that here as well. Okay. So this is going to be our container registry name, ECR demo. We have here. Then we have the image repository. Again, you can check here what value is expected. So we have the repository name, and the tag is going to be the same that we've used here. So the same image that we just built, we want to pull there and deploy. And again, going back or taking my cursor back here, I'm going to add that. And that's the task for deploying our application to the dev environment. Now, there's one more thing that we can actually optimize here, which is we're using these values for the container registry, repository, Docker tag in multiple places. So what we can do is actually, in order to avoid repeating the same values, and we're going to actually need those for deploying to test and prod as well, we can extract them as variables. So right here, I'm going to define a variables section. So the same way as Pipeline or Azure makes some variables available for us, we can actually, in addition to those, we can define our own environment variable, and those will be accessible for all the stages, all the tasks in the pipeline. So these are kind of global variables. So first, let's define the image registry. And this is going to be ECR demo. Let's also create a variable for image repository. And that's going to be the value. And let's also take this, put this value in a tag environment variable. And now we can just go ahead and reference those global variables that we just defined instead of those fixed values. And just like you reference the already existing environment variables using $ and brackets, you can do the same. You can use the same syntax for our own variables. So that's the syntax. Again, $ squared, $ brackets, and variable name. And here we're going to add the tag. And we have those values used here as well, so I'm just going to replace them here as well. So we have the registry. And the different attribute names for the same values may be sometimes confusing, but that's why those information icons are there, so you can check what value is expected for each parameter. Awesome. So we kind of optimized our tasks or our stages. and the pipeline code not to repeat some of the values. And again, you can do this actually for each and every value here if you want to. We can also substitute the values for the subscriptions as well, or you can just leave them as well. So you can optimize and use variables for any values you want. So with this, actually, we can also already test our pipeline and see if it deploys to our dev environment. And to do that, we're just going to click on save, again, commit to the main branch, and this will trigger the pipeline execution. And let's wait for those stages to complete. All right, so going back to the pipeline, there is one thing that I want to note, and this is actually a little bit confusing, threw me off a little bit, and I made a mistake. So make sure to correct that as well before running the pipeline. So basically here we have the place where we substituted the fixed coded values for the variables. We have container registry here when we are executing Docker build and push command. And this is actually the value for image registry connection. So the service connection name for Docker registry. So this is the value for it. So I just renamed the variable name actually to image registry connection with this value. And down here we have a Docker namespace, which is actually the image registry. So I've created its own variable, environment variable for that. And the value of that is IDEO demo in my case. So make sure to set those values correctly. So this is the registry connection name, and this is the registry name itself. And the repository names are the same. So make sure to make those adjustments as well, just like I've shown here. And with that change, we can actually run the pipeline.
So now that our pipeline has run successfully, let's take a look and see if our dev environment has actually deployed. Now I can see here in the Azure portal it is, and I can click on the dev environment and it pulls up our website. And I can see that successfully we've been able to deploy the changes that Nana put in her task. So I also want to go into the dev environment here, and we can look at the deployment history into this environment. And this connects directly into Azure DevOps itself. So I can see that we've deployed this. Now it did tag it to production because in the Azure sense, this is a production environment, but this is really tagged as our dev environment. So we could potentially change that wording, but that just sees it as a production element. So don't worry about that. But this is our dev environment, as you can see here, ADO demo-dev. But if I click on this build, this takes me back to her exact build that ran, and I can see that it was successful. So we can see end to end, we have that traceability of the build to our image and to our website. So back over to Nana now as she builds out the rest of the pipeline for the other environments.
Awesome. So back to the pipeline. Now we actually have a pretty good structure. So we have the two main stages of building and deploying, and the rest of the deployments are actually going to be pretty similar. So what we're going to do is we're going to actually copy this whole stage which deploys to dev, and as the next stage, we're going to deploy to the test environment. And because it's mostly the same logic, we're just going to substitute those values. We're going to call the stage and test the job deploy test. We're using the same task that is deploying this time to Azure Demo Test environment. And so that's the web application name that we already have existing on our Azure cloud. And all the other stuff will actually stay the same because we're using the same service connection. We're using the same registry. So we want to take that exactly same image that we deployed on dev. And once it's been tested and made sure it works there, and as April showed, we were able to see the application from browser. We can actually take that image and promote it to the test stage. So this is what we're doing here. Now, what is the actually purpose of having a test stage? Most cases, between the dev and prod, you have some kind of like intermediary stage. It could be test or staging, whatever, and it has its own use case. So in this case, it could be, for example, if you have manual testers, because you don't have so many automated tests for your application, you actually need someone to manually go and actually make or test your application. So this could be an environment where the testers would go and actually test those features and bug fixes that were deployed. And if they find something is not working, they can kind of assign it back to the developer saying, hey, your feature has this issue, please fix it. And then you kind of go through the same life cycle of developing and releasing that developed code again. So now in this case, we could automatically, after deploying to dev, deploy to test. However, a realistic use case could be if manual testers are working during the day. Obviously, we don't want to automatically update the test environment with a new version suddenly. Instead, we may want to do it maybe once in a day or once in 2 days, depending on your workflows. So for this test stage, we can add basically a trigger to that stage that says only trigger or only deploy to test maybe at night when nobody is working and we're not interfering with anybody's work by just randomly deploying a new version on that environment. So we can actually add that trigger to our jobs, so kind of gatekeep our stages and add a condition that says only execute this task or this whole job if this was scheduled. And we can do that very easily using a condition, as I get suggested here. And I'm actually going to copy the whole condition, and I'm going to explain what this means right here. So basically what this condition does is it says if the previous one was successful, so only if dev deployment was successful, then want to deploy to test, but not immediately, only if it was actually scheduled. And we can then define when the schedule will run, or when the schedule will basically run. And you can actually add that schedule logic here using a cron job expression, or I actually find it better to define it in the UI. So what I'm going to do is I'm going to go to the pipeline and open another edit mode. And right here in the edit mode, you have something called triggers. And this is where you can actually use the UI to define the schedule. And I find it easier, first of all. And second of all, you can actually use local time. So if you add the schedule, right here, you can decide when is this build gonna run. And you can choose the days of the week, and you can use the time. So for example, in our test case, we're for test deployment, we can say, you know what, execute this at 3 a.m. On UTC time, or in my local time. In my case, I'm actually in Central Europe, so let me choose my local time, like this one. So we can say execute this Monday through Friday at 3 a.m. So again, when deploying it, we're not interfering with everybody's work. So the next day when the testers come, they have a new version to test. And in our case, we can actually test this. So I'm going to use the time that we have now. So it's going to be 18. And let's give it 2 minutes. And once we have that, and as you see, the configuration is super simple. That's why I prefer the UI part better than defining the cron job. So let's save this. And in 2 minutes, basically, the pipeline should get executed. So while we are waiting for that one to trigger the pipeline, we can actually keep on editing and define the next stage, which is going to be deploying to production environment. Again, this is going to be pretty much the same code, because we're using the same web app deployment, but we're deploying to a prod environment. So we're going to change the namings here everywhere. In this case, we don't need a scheduled deployment, because we're going to have a different gatekeeping here for production. And as I said, we are deploying to a prod environment. Everything else is the same. We are taking the same image that were testers basically tested. They decided it's fine, and I want to promote it to prod. However, again, prod is very sensitive in many projects. Probably in most projects, people don't feel confident or comfortable just deploying to prod automatically. There need to be some kind of decisions made and lots of testing and security checks and management decision basically involved in deciding, you know what, now we can release that version of the application to the production. So also a very realistic use case would be to actually manually approve any deployment to the production environment. And this is going to be similar to the condition that we have here. It's a condition that says, you know what, we are not automatically deploying. We are going to add a manual approval job, right? So in this case, it is actually a separate job. So what I'm going to do is right before deploy prod, I'm going to add a job. And let's call this approve release. And let's do steps. And we're going to use a task for this one, actually. And I'm going to do manual validation. So that's the task. We can basically notify users. So whenever the deployment is ready to be deployed to production, we're going to notify these people. They get an email. A job is waiting for your approval, for your manual approval. Please validate it. And we can also write instructions here saying, please validate and approve deployment to prod. And now, when we set a manual validation step, obviously we don't want to wait forever, but we also want to give those people time enough to validate and approve that, right? So we have some timeout, and when that timeout is basically over, either we decide, you know what, the pipeline is rejected, so automatically we don't do anything, we don't deploy to prod, or we resume. So depending on what we want to do. In our case, let's see, if nobody approves it, then we reject the pipeline after the timeout is over. So moving my cursor here, let's actually add this. And let's define the timeout. So let's define how much time do we give the reviewer to manually approve this. And after that, the pipeline will kind of abort, right? So we can define timeout on a job level. So we can say this job will have a timeout of 3 days. So that's how long we can wait. And we can also define a timeout for the task itself. So we can do that on the task level, right? So let's say the task has a timeout of 1 day. And there is one more thing that we have to add here, which is where this specific job gets executed, because otherwise it's not going to work if we execute it on a Linux machine, and this is going to be a server. So basically, this is just going to be executing in a sandbox where it doesn't need actually a Linux server to execute. So we have to provide this parameter here so it actually works. Right. So with this configuration, we should have deployment to dev happening automatically, deployment test happening once a day on the schedule, and then deployment to production only happening if someone manually actually approves that deployment. And with that configuration, we can actually save this pipeline. And since the time of schedule already passed, we can also go back to the pipeline and see that it was the previous one actually. So this one. So 3 minutes ago, so this was the schedule that we defined, was actually executing. So I can actually cancel this one and just run the current pipeline. So let's actually see what happens. First of all, we have 4 stages now because we added deploy test and deploy prod. So now, once the build app is successful, it should automatically deploy to dev. So this stage will automatically get executed. And after that, it will check whether the time that we defined in the schedule or in the scheduler is actually equal to the current time. If not, it will actually skip the deploy test and deploy prod stages altogether. So let's actually wait and see that happening. Okay, so as I said, this is gonna skip the deploy test because we haven't configured scheduler for that yet. So what I'm gonna do is I'm gonna actually cancel this one again. And I'm gonna create a new schedule so that our pipeline actually goes all the way through to the production, so we can manually approve it. So going back to the triggers, let's actually define again time that will trigger the pipeline in, let's give it 1 minute. Let's go. And as soon as 24 hits, then we should see a pipeline triggered. So let's wait for that a little bit. All right. Okay, so we have 6:24. And let's see. There you go. So our pipeline is running, and this will actually execute the deploy test stage as well because it was triggered from the scheduler. So let's wait for that to go all the way to deploy prod, where we'll have them to manually approve the deployment. All right, so as you see here, the deploy dev and deploy test stages were executed successfully. And once it got to the deploy prod stage, it now is actually waiting for the manual validation. And you see here, it says 0 from 1 manual validations passed. And if I click directly inside, it will actually show me the pop-up where I can either reject with a comment. So let's say in a realistic scenario, the test environment was deployed, the testers tested it, then were a couple of discussions whether to release it or not. And once the final decision was made, it could, the approver, whoever it is, either rejects or resumes the pipeline. So, and optionally, you can provide a comment that says why you reject or why you resume. And we can actually click on resume, and this will basically the approve release task that we just approved will go jump to the next part, which is deploying to prod. So let's wait for that one as well. And you see it's successful. So now let's actually go and see the application deployed in the prod environment.
So you can see we've successfully been able to launch our website into our production environment. So we've deployed the exact same website into different environments. Why? Because we want to be able to test it, whether we're running unit tests or UI tests, etc. And we can run that without going to production directly. And Nana very smartly set up her pipeline to protect production. And we can test our code and our image all along the way. So we can also go into our production environment in Azure. We can see where it's been deployed to. And the other thing we can see is, again, that build that she just did. If I click on it, it takes me to her build that shows it was successful, and I can see how everything went through. So we successfully were able to deploy that through the pipeline. So back over to Nana to finish off pipelines.
Awesome. So we have actually created a full pipeline that basically deploys on 3 different stages. And we have respective, so based on or depending on the environment, we have the respective gatekeeping to decide whether we are promoting to the next stage or not. So now let's actually do something, the last stage or last task in the pipeline, which is very interesting from the concept of deploying to multiple environments from your pipeline. So right now we are deploying to Azure Cloud. What we're going to do now is add a stage that actually deploys to another prod environment, which is on which happens to be on AWS platform. So we're going to deploy to a very simple EC2 server, which already exists. So I have it configured already. It already has Docker installed on it, so we can actually deploy our Docker image to that environment. So this is to showcase basically that you can take the same pipeline, you can go through the stages, and then finally maybe have 2 different environments you can deploy to, both or even to more environments. So let's actually do that as well. So going to the edit view of the pipeline, I'm actually going to grab the whole deploy to prod stage because we're going to reuse some of it and copy it here. And let's actually rename these to deploy prod Azure. And let's call these deploy prod AWS. And we also want to have manual approval for deploying to AWS because it's also a prod environment. So we want to kind of protect it and make sure that no automatic or casual accidental deployments happen there. So someone actually explicitly decides to do that. So that part will stay the same. We have the same manual validation task. But this is the one that we're going to change now. So instead of deploying to Azure platform, we're going to deploy to EC2 server. So the way we're going to do that is actually using the most basic, simple, low-level SSH commands, right? And this means actually that you can use the same code that I'm going to show you now for any other server, whether it's on AWS or on-premise or whatever it is actually going to be the same code. So let's actually do that. First of all, So, okay, so we have the steps and we're going to do this in 2 tasks. First task is the script, the low-level script that I mentioned of SSHing into the server, basically, and executing the command. And we're gonna use the script, which is actually something that we haven't used yet. So this is the first time, and this is a substitute for a task. As I said, tasks are ready scripts, so to say, ready packages of scripts that under the hood have these low-level commands. And this script is basically just basic Linux commands. So if we want, and this is simple YAML syntax, if we want a multi-line script, we can use a pipe. Well, where's the pipe? So pipe is basically for YAML syntax for multi-line script or multi-line string. So on this level, we can write multiple lines of our commands. So the command that we're going to use is SSH. So we want to SSH into the EC2 instance that, as I said, I already have available. And for that, we need a private key that we pass using this -i option. And then we're going to substitute that with the private key. So now I'm just going to put a placeholder here. And we're going to need username of that Linux machine. In my case, it's an Ubuntu machine, so that's the username. And we also have the IP address of my EC2 instance, which I'm going to copy in right here. So that's the public IP address of my machine. That's the Linux username, and we actually need the private key. So how do you get the private key? Well, I went ahead and actually edit. So if I go to the pipelines, actually edit the file already. So if I go to the pipelines library and secure files, I have my private key already uploaded. So that's the SSH private key for connecting to my server, and that's what we're going to use. So the way it works in the pipelines, if you want to actually use a secret file or a sensitive file that you have in your Azure configuration, we actually have a task for that downloads that secure file on wherever environment this current job is executing. So it makes it available for the next task in that job. So right here, before that script, basically in the job steps, as a first step, we're going to add a task. Let's actually edit from here. It's called download secure file, and a name of the secure file, which is this one right here. And click add, and there you go. So that's the name of the file that I just showed. So that's the name, and this is the task name. And the resulting file that we have, we can reference it in sort of a variable name, so we can call it SSH key. And now this is the nice part, because we can actually reference the downloaded secure file in the next task or next step of the job by simply using the name, reference name, and in this case, secure file. That's it. So this gives us access to that downloaded SSH key file, and this command will connect us to the EC2 server. Now, there's one more thing we need to do before we actually use that file, because by default, when it gets downloaded into the environment, it's gonna have two loose permissions, and we will get security warning for using a secure file that has no restricted permissions. So we're gonna fix that first by simply setting the permission to 400, so nobody's able to read it or execute it or have access to it, except for the file owner. And again, we're going to reference a file like this, and there you go. Now, so this basically just connects us to the server, but we want to actually execute a command to run the Docker container on the server, right? So we're going to pass in the Docker run command to the SSH command. And we're going to do that simply by using those, what are those? Those characters. And on the next line, again, we can actually write multiple lines of any Docker commands we want. So the first command will be to stop any running containers before we start a new one. And I'm just going to copy the code there, which is an expression for finding all the containers that may be running or not, and removing them. So with docker ps -aq, you basically get all the containers, whether stopped or running, and it basically stops them if they're running and removes all of them. So this makes sure that we have no container running before we start up. Otherwise, we'll get an error and it will not start up. The second one will actually be to start our newly built image container. So let's do that. Simple docker run command. We're going to run it in the background so it doesn't actually hold our pipeline execution, and it just silently executes the task. We're going to bind the port of the container, which is 80, to host port 8080. And finally, we need the fully qualified image name and the tag. And again, I'm going to copy that. So this is basically the image repository variable that we have defined here, and the image tag, right? Sorry, that we have defined right here as variables, image repository and tag. And this is the fully qualified image name in order to be able to pull and run the image on the environment. And do not forget to close the quotes that we open here, right here at the end. And that should be it. So let me just check that. So we have manual approval for deploying to the AWS platform as well, to EC2 instance. And here in actual deployment, we are first grabbing that secure file that we have available here, downloading it into whichever environment executes this job and this task. And just with simple, very low level SSH command, we are connecting to the server, and we are running, or we're starting the container on that server. So let's actually execute this one and see the application running on EC2 instance. However, let's actually go back to the edit mode. This will actually skip the test and prod deployments. So just for the sake of the demo, let's actually remove this one, the test stage, because it only runs if the job was scheduled. So I'm going to save that as well. And there you go. So we can cancel this one. So I removed the deploy test stage because it only run and get to the production if it was scheduled. So just for the sake of the demo and the time, we have removed it. So after deploying to dev, it will wait for our manual approval for both deploy prod Azure and deploy prod AWS stages. So let's wait for the pipeline to complete and see the results. Okay. So let's do the manual approval here. And this will trigger another one for deploy production on AWS. So let's resume this one as well. And this should hopefully deploy to EC2 instance. So let's see that. Okay, so our job or our task for deployment actually failed. And if we go inside and check the logs, we see the reason for that is that host key verification failed. So basically, when you're SSHing to a new host for the first time, you have to kind of prove that in interactive mode. And we're going to actually have to fix that by adding an option here for disabling that strict check mode. So we're going to add that option to the SSH command. So I'm going to do that real quick. So this will basically just disable or shut off the host key checking request, and that should fix the issue. So I'm going to save and run the pipeline again. Cool. So as you see, our deploy prod to AWS went through as well. So now we can actually check that the application is available from the browser for that server. So if I go back here and let's actually grab that public IP address and the port where we exposed it on, there you go. We should see our application successfully deployed on EC2 server. Awesome. So basically, we were able to create a pipeline, a full pipeline with that basically takes the code changes, that gets automatically triggered whenever something in the repository changes, including the pipeline file, and builds the image of the application, pushes it to our Azure Container Registry, then it deploys to development environment. Before that, we even had an image scanning that you can add to make it more production grade. After dev, we have added deployment to testing, which is triggered by schedule, and then deploy all the way to prod on 2 different environments on Azure and AWS. So that's our complete end-to-end pipeline. So we just saw a demo of building a CI/CD pipeline where we basically produced an artifact, which in our case was a Docker image. And then we took that artifact and basically promoted it all the way to prod, but going through the stages from first deploying to the dev environment and to test, and then promoting it to production if every one of those stages went fine, right? So artifacts is something that you actually generate from your application. It's the packaged version of your application. It's movable and it's deployable to an end environment, right? This could be a server with an operating system. This could be a platform like Kubernetes cluster. This could be a service or serverless platform, whatever. So artifacts are basically what we produce when we want to deploy an application. And depending on the application and which technology or tech stack we use to write that application, we're going to produce different artifacts. As I said, Docker kind of became the standard artifact format, but there are also applications that do not produce Docker or CI/CD pipelines that do not produce Docker images, and teams that still work with other artifacts. So for other types of artifacts, for example, that produce jar files or WAR files from Java applications, that produce maybe zip files or tar files from JavaScript applications, or NuGet packages from .NET applications, those need actually a storage, just like Docker repository, where they can store the artifacts. So Azure DevOps actually also provides that feature called Azure Artifacts, which you can use as a storage for this type of artifact types for different applications. So let's actually see that in action as well.
Now we're going to go over Azure Artifacts. When we connect artifacts, we can connect to any artifact, any kind of package type. to any pipeline, and it helps us to share our code efficiently. Now we can connect to a feed. So if I go to connect to a feed, I can do a NuGet feed. I can do a Visual Studio feed. I can also connect things like NPM and Maven. If you're working in Python, maybe pip or twine, we can also just hook in universal packages. So the artifact repository in Azure DevOps is as simple as that. You can also do your own custom artifacts that you want to do and share amongst your different projects all across your organization. And it's just a secure place to put them. So that is Azure Artifacts in a nutshell.
So another thing that is also super, super important in CI/CD pipelines, and I mentioned that, but we didn't actually have that in the demo, is the tests, right? So basically, going back to what DevOps is and why we need it, DevOps is there to basically move any impediments and anything that slows down the release process of taking our application changes and releasing it all the way to the production. And one of the major bottlenecks in that process is actually the testing, because we can't release the code changes if we're not sure that it's 100% working, it didn't break any existing features or any existing things in the application. And for that, we need extensive testing and testing on many levels, right? You have the unit tests, you have the application performance tests, functional tests, and these kind of test different aspects of the application. And in some cases, depending on the application and how complex it is, it could be that you have lots of extensive automated tests, that you have test engineers dedicated for writing those automated tests, but you still have some use cases that you can't actually catch using those automated test scenarios, so you still need a little bit of manual testing. So all those test cases are basically something that your team has to go through and kind of check off the list, depending who is executing them and who is checking them. And Azure DevOps actually has its own feature where you kind of have a place to define those test cases, and as well as kind of have a unified view of all the tests that you have to go through to make sure your application really complies to everything and it is deployable. So April will show that to us as well in demo.
Now we're going to cover off Azure test plans. Now, again, these are for manual testing. So how do Azure test plans work? These are great for manual and exploratory tests. Again, like Nana said, you can have UI tests, unit tests, end-to-end tests. We can have all sorts of tests, but this is going to be for planned manual testing where user acceptance testing can be taken. We can also use this for stakeholder feedback. So if we're looking to get feedback from marketing and sales teams or maybe exec levels, this is a great way to do it. It gives us something to see in a nice little pretty graph, but usually we kind of tend to put our testing in our CI/CD pipelines, right? We put our unit tests in before we deploy our code. So we look at different ways to do this, and this adds into our traceability element as a high-performing DevOps organization. We want to be able to link these test cases and the test suites to features and our user stories. So this is a really good way to do it. So we're going to look at some ways we can show off this reporting. To add a new test plan here, we click on New Test Plan, and we enter a plan name, and I can just call it Our Test, super creative name, and I give the area path, right? I can do ADO demo. Now, again, if you're working on multiple projects with multiple teams, your area path would potentially change. I can also add this to an iteration. I can add this to the existing sprint. Maybe Nan and I need to look at testing in this existing sprint with some manual tests that we did. So I'll go ahead and create the test plan, and from here, I'll add a test case. Now, this will look like, when we create this test case, almost like a task, and this will then show up in our boards. So I'm just going to call this infra monitoring, maybe. We're going to keep the design phase. Again, we've kept it in our ADO demo area, and we can add it to our sprint. But if I click on the ADO demo area, I can add it to infra and monitoring to get more definition on our reporting. And then I can add steps here. So I could say review monitoring. And I could say pull the monitoring reporting. You could maybe do some load testing in there, and then produce reports and compare. So these are very manual tasks that we've put in. I can add an existing work item as a parent, but maybe I want to add a link to an existing item. So let's see what we have. Well, we have some other test plans in there. I'm going to add this to our change in website. That way we have full traceability end to end. I can add some comments if I want to. And I can add some link in our development side. So maybe if I want to open up a branch to this, if I needed to, or I could open up a pull request. And basically I can track this through a build if I also needed to. This helps us with the automation piece of, the traceability piece. I can also add tags. I'm going to go ahead and add a testing tag. So I'm going to go ahead and save and close that test case. And then from here, I can add other options here. I can do a new testing suite. I can add configurations, and I can assign testers to run all the tests. So I am myself a tester. I can also look for Nana. Look at that. I'm going to bring her into this, and we're going to send an email to run to our testers. So we can send an email communication across. We can also send this to a group of people as well. So we can see the existing tests that we've put out. We can look at the execution, and we can chart it, and we can start looking at how we do this. And then we can start adding in new test suites. We can do a static test suite. We can do a requirement-based suite or a query-based suite. Query is really helpful to pull into the queries that we saw earlier in Azure Boards and do it that way. So we can query a work item type with the area path under ADO demo, and we can run this query. So we get a few things, and actually they're all the other different test cases that I've already created. So I'm going to go ahead and create this suite, and there's a lot more we can do with it. So that's pretty much the way we do it. So I'm going to go back to my other test plans, and I did one for Sprint 1 testing already. I did it for the website configuration layout. I can do some basic testing, and I also want to test our monitoring. So I've already executed those, so I could get a bunch of runs on our environment. We can also see that they both passed. We can see that as an outcome under the latest 2 runs. I can also see the chart and see the history of how it looked. So again, we want to give that visibility and that reporting to maybe the marketing people. So we changed our website. Maybe there's an impact on marketing or sales because we made a really positive change to our website. So we can pull these manual tests out. The other thing we can look at is our progress report. We can see that we have 1 test plan with 3 different test points. We can see that 2 of the 3 test points have run with a 66% acceptance rate. And then we have a 100% pass rate down here of those. It looks like we have 1 that hasn't ran. So we could look at maybe manually running that or even automating that to run. We can also then configure parameters around our testings and get a lot more involved in the parameters and values set against our tests. I don't have any configured in this, but we would need to go through our configurations and add a bunch of that in. So if you're looking to test against maybe a specific browser or an operating system, you can add those in here. And then we can see all the test runs in a list that we could export, share, and see the history of all of our test runs. Now that we've covered off pretty much every aspect of Azure DevOps from the we've seen the overview, we've seen the boards, the repos, the pipelines, the test plans, the artifacts. We've covered off every single facet of Azure DevOps. But I want to go ahead and touch on compliance real quickly, because it doesn't matter how good we think a tool is or how useful it is. The compliance piece is huge, because when we talk about security, security should literally be in every single thing we do. So I've actually governed this repository so we can get reporting off the back of it. So we've built in security from day 1. We've built in security into how we authenticate into Azure DevOps. We've secured our pipelines. We've secured our images. We're securing all our resources from beginning to end. But I also want to look at the governance side of this. If any people work in the financial industry or the healthcare industry, this is absolutely critical. So this is scanning our repository where our code is sitting for any vulnerabilities. Now it has found a vulnerability in here. It's an alert. I can look at it. We can see that it's come from our checked in files. So there's an issue in one of our files. It's put it in as medium severity. It's give us a recommendation. So we can very much, and actually a location of where our code is. So we can look at to upgrade this and to fix this issue. So we can dismiss it if we wanted to, or open a task or a bug in our code. The other thing we can look at are the components here. So we can see all the components in our repository, all the different releases that are in there and the packages and how they've been registered. So it has a list of all these components and these dependencies that we're pulling our code from. Now, compliance is really critical if you're using things like open source projects, because that's huge. So we can see again where all these commits, we can see when it was committed. any changes that happened. We can see that 42 changes were made here. We can look at the build number. We can trace the build through, and we can look at the code commit and the branches in which and who did it, right? So we have this full traceability end to end. We can also look at assessments. We can start compliance assessments if we need to. And there's different products you can hook in as well. There's always third-party products that can hook in to help you write, to be more compliant and to fulfill that for an organization. So we can add a new product service here and start hooking that in to what we want to do. So this currently hooks into Service Tree. And then you can browse all the different third-party tools that you can hook in for compliance. So we're not going to go and set that all up because that's quite in depth, but it's good to know that that exists for Azure DevOps. So I'm going to bring Nana back in, and we're going to wrap up, and hopefully you've learned something today in our Zero to Hero episode.
So that was basically our full demo of or Zero to Hero of Azure DevOps, and we covered a lot of different stuff, a lot of different parts of different features, started from the boards all the way to compliance. And I really hope you guys learned a lot and you are actually ready to use this platform now in your projects, or you actually found some of the features that really solve some problems or really fit into your projects. And you basically are excited to test it out and start using the tool.
Awesome. And thank you, Nana, for joining me on this video today. Such an honor to have you alongside with me to show off Azure DevOps and all the features. So I want to thank everyone for tuning in. We're going to put all the links in the show notes so you can access it. And I just want to say thank you to everyone out there, and go forth and write some awesome code.